have with us a very honorable, distinguished speaker. It's an honor and an absolute privilege for me to introduce Dr. Abdulla P, who presently serves as a...
Ashwin, your audio is not clear.
Ashwin?
Your audio is not clear.
Sir, 1 minute, sir.
Sabik sir, ഒരു മിനിറ്റ് ഇതൊന്ന്
കുഴപ്പമില്ല. സാർ ഇപ്പൊ കേൾക്കുന്നുണ്ടോ?
ഇപ്പൊ ബെറ്റർ ആണ്.
Okay, sir. Good evening, all. Today we have with us an honorable, distinguished speaker. It's an honor and an absolute privilege for me to introduce Dr. Abdulla P, who presently serves as a professor in the Department of Electronics and Communication, School of Engineering, Cochin University of Science and Technology. Since 2019, he is the chair of IEEE Antennas and Propagation Society, Kerala chapter. In the past, he has served in many positions, including HOD of MES College, Kerala, School of Engineering, CUSAT, Kerala, and as director of Center for Incubation Technology Transfer and Industrial Collaboration, CUSAT. He got his PhD degree in Electronics and Electrical and Communication Engineering from IIT Kharagpur in 2009 and has guided several PhD students. He has authorized numerous technical papers in national and international journals and conferences. He has been awarded many sponsored projects from the Government of Kerala and Government of India, has delivered several invited talks and also organized several workshops and seminars. It's my honor to welcome and invite Professor Abdulla P to head today's section. Welcome, sir.
Okay, thank you, Mr. Rashin, for your nice intro. Okay. Is it okay? I am putting it in slide mode.
Yes, sir. It's view.
Okay, thank you. So, good evening to all. And first of all, I extend my sincere gratitude to Dr. Krishna and IEEE Malabar Section for giving me this opportunity to share my thoughts and experience with you people. It's a new thing. So I am talking today about electromagnetic interference and electromagnetic compatibility. In this title, you should emphasize the word compatibility. How compatible a particular system is. Nowadays, you are dealing with large number of electrical and electronics instruments. They are mostly controlled by a processor, which produce large number of frequency components. And because of this large number of frequency components, they interact each other, and as a result, they are going to be malfunctioning. There are lots of examples because of this malfunctioning, which has led to a large number of accidents during 60s and 70s. Now, this is a situation. You should have some knowledge, some basic knowledge, how to operate our electrical and electronic equipments compatible to each other, specifically on in the drawing table state itself. For example, when you design a large equipment like an aircraft or a ship, then if it is a ship, at the decision or design table itself, you should know where to keep your main engine, where to keep your electrical engine, where you should keep the navigation and control equipment, where should be the antennas, where you should keep the radars, and so many electrical and electronic appliances will be there, like freezer, a heater, so many things. If you are not taking the decision at the drawing table state itself, what happens after developing the structure? You will move bits and pieces here and there, and ultimately you get no solution. You may have to discard the entire system, which may lead to a huge loss of money. So what do you mean by compatibility? A compatibility means one equipment causes the other. So for example, I will show you one typical figure. You want to see it here. Okay. Here you see, you are very familiar with your mobile phone and computers, personal computers. When you operate on a personal computer and keep your mobile near to the monitor or on the table itself, and somebody is trying to contact you, so what happens? Your mobile phone start by transmitting the power when you make a call of the order of few milliwatts or sometimes even 1 watts or etc. So this radiated power might pick up inside the wires in the PC. And suppose if you connected the PC to multimedia, to the speaker and all, you can see some humming sound in the speaker, or else sometimes, you can see some flickering on the monitor. So what happens? The power signals which is radiated from the mobile phone is interacting with the PC which you are sitting in front of it. So that signal is an interference to the computer. So another example is very familiar. During lightning season, you are very well experienced that there is a huge pickup on your transmission line. So that may sometimes destroy or permanently damage some of your electrical and electronics apparatus equipment. So we don't have any control over it. That is another interference. So for example, another example, if I say, suppose if you want to have a mobile service center in your station, then until and unless if the company is not making a terrain survey, you can't have a very good service provider. Because of the destructive interference, there will be loss of signal certain location whose company's base station and antenna may be somewhere else, and meantime other company's signal whose base station and antenna may be located in some other location. You may have a good reception at that point. So there also it is due to the another type of interference. A typical example, another basic nowadays you are not using, in AM radio communication. Suppose if you tune to a particular station, you might have heard of a faint signal which is entering into your tuned channel where you don't have any control over it. So that signal which is entering to your particular setting is an undesired signal that is interfering with your desired signal, and your system is behaving in an undesired fashion. That is a malfunction. So with these few examples, I hope you understood what is compatibility. A compatibility means one equipment causes the other. So as I mentioned, there are large number of accidents which happens during 60s and 70s due to such incompatibility. So for example, you take this, look at this picture. This picture is taken during Vietnam War, 1967 July. This is a US carrier ship. What has happened? The RF energy, high frequency energy from an aircraft radar coupled into an improperly shielded cable connector on another aircraft, causing the launch of a missile on the flight deck. So the missile struck a wing-mounted auxiliary fuel tank on another aircraft, causing a massive fire and explosion. So 134 sailors and airmen died on the spot, leaving on more than 150 injured casualties. This is a typical example of EMIs. Similar such different large number of examples you can point out. Even in India also, in 2000s, when the Marines, they were conducting their regular exercise near Visakhapatnam. You know, the Marines, they need to take the missiles, store, etc., clean it, keep it, even though if there is no war. Every week they are doing their routine business that I will explain to you later. So due to the electrostatic discharge, one of the missile got fired, and on the spot 4 Marines killed. So similar large number of examples you can see if you Google. Now, apart from that, after 1960s, you know, we started switching from analog to digital domain. You know, though already our electromagnetic spectrum allocated for different purposes, already it is fixed band. When we switch from analog to digital, due to its inherent property, quality, etc., but what will happen? The bandwidth occupied by the digital signal is almost double than the analog signal. So there is a chances of overlap and hence the interference. Okay. Now, the objective of this course, electromagnetic interference and electromagnetic compatibility. Normally people will say EMC, electromagnetic compatibility, is how to design electronic system for electromagnetic compatibility. They should work in a proper way without interacting the other one. Now, a perfect electromagnetically compatible system, it should satisfy these 3 criteria. Look at this criteria. What is a perfect electromagnetic system? It does not cause interference with other systems. Second one, it is not susceptible to emissions from other systems. This is important. It is not susceptible means it is not sensitive to emissions from other systems. You can't give a guarantee how the other systems are behaving. For example, suppose if you are a peace-loving person, and if you don't want to interfere with others, and you are sitting in the class very quiet and calm, but you can't expect how others are behaving. Suppose if others are making interfering you, it is you should not malfunction even if others are misbehaving or malfunctioning you. Similar is the case for the electronics and electrical appliances also. Examples are, suppose the case of launching of satellite, or the time of testing of nuclear weapons, nuclear tests, or in the case of a war field. At that time, you can expect a large number of frequency spectrum signals are getting produced. At that time also, we should monitor these satellite launch and equipments in a proper way. For that, our equipment should work in a nice way without malfunction. So we should ensure that. Then the third one, it does not cause interference with itself. You look at any system, if you look into any system, that system consists of sometimes a few, sometimes thousands of subsystems. So for example, if you take the PC itself, you know, PC, you have motherboard, SMPS, memories, monitors, keyboards, mouse, etc. So many peripheral devices. If one of the system is malfunctioning, then what will happen? So our entire system will behave in an undesired fashion. Okay. So if you have any question in between, you can ask. We will pause and I will answer it to you. Now, the EMC is concerned with the generation, transmission, and reception of electromagnetic energy. These three aspects of the EMC problem form the basic framework of any EMC design. So I think I have a block diagram. Yeah, okay. This will be more clear. A source, also referred to as an emitter, produces the emission and a transfer of coupling path transfers the emission energy to a receptor, to a receiver, where it is processed, resulting in either desired or undesired behavior. Interference occurs if the received energy causes the receptor to behave in an undesired manner. Transfer of electromagnetic energy occurs frequently via unintended coupling modes. However, the unintentional transfer of energy causes interference only if the received energy is of sufficient magnitude and or spectral content at the receptor input to cause the receptor to behave in an undesired fashion. So you look at this block diagram. You have a source here and a transfer, a coupling path and a receptor. If there is a problem, then you have a problem, you need to address it. If there is a problem with the transferring coupling path, wireless and wired, if you are not addressing, you will face the problem. Receiver, again, if receiver is also producing some undesired signal, then again there is a problem. So for example, you take the typical case. If you have two devices, suppose one device is your mobile phone, another one second device, you assume it is a PC. When the mobile phone, if you are connecting to your charging through a 230 volt power line, so the mobile phone will radiate. So the radiated signal is falling on your PC. That's what I explained. So this is the RF signal which is coupling to your device 2. So how do you increase the immunity of the device? We will increase the immunity of the device by giving a proper shielding. Even though shielding is there, somehow if the signal is perforated inside the device will malfunction. And another way by which the signal will enter is our power line. I will explain this in detail. That is a conductive coupling. This one is a radiative coupling, this is the conductive coupling. Because you are connected your mobile phone to the 230 volt power supply, the same line is connected to the PC also. So whatever the high frequencies that is emitting from the mobile device to the power line, 230 volt line, is getting coupled to your device to the 230 line. So for that, how do you block it? We need to insert proper filters, etc. in the device. That is the way how we will increase the immunity. So something happened. Sorry. Now, the next question, how do you get rid of this interference? How you make the equipments compatible to each other? What is the solution? Now I am telling about the solution. What is the solution to avoid these accidents due to electromagnetic interference or else electromagnetic pollution? You look at these 3 points: suppress the emission at its source, then make the coupling path as inefficient as possible, and number 3, make the receptor less susceptible to the emission. Look at this one by one. Suppress the emission at its source. Is it possible? Which means you don't emit your electromagnetic signals, which means don't emit, don't transmit anything, stop all your work, which means 0 is the solution. It is not possible. Second thing, make the coupling path as inefficient as possible, which means your coupling path, I have shown you, mostly I am talking about wireless. Suppose if you send your signal through an anechoic chamber, a chamber, then if it is inefficient, nothing comes out. In meantime, your signal also will lose. The third one, make the receptor less susceptible to the emission, which means your receiver you make less sensitive to the emission, means meantime you may lose your desired signal also. See, now the situation has become drastic. We don't have any solution to get rid of these EMI incidents. We can't make an 100% solution. See, now the situation has become similar to automobile pollution. You compare your automobile pollution, you know that the automobiles will produce a lot of polluted carbon monoxide, fogs, etc. to the atmosphere. So, how we control these unwanted pollutions from the automobile? By imposing certain laws. Okay, the government will impose certain laws saying that your vehicle should not emit these pollutants more than this level. Now, hereafter I am talking to this electromagnetic pollution. This is almost similar to electromagnetic pollution. Then how do you control this electromagnetic pollution? You can control it by imposing certain laws similar to automobiles. Now, who will control these laws? The government can control. Government can impose the laws pertaining to the emitted various frequencies from the different electronics and electrical appliances should be below this level. If it exceeds, then such equipments are not permitted to sell in the so-called developed countries. I'm emphasizing the word developed countries, US and European countries, so-called Western countries. They made this stringent rule for all electronics equipments. So they should not interfere, they should not emit more than this level. And meantime, what is your immunity, your instrument's immunity to survive the so-called pollutant electromagnetic environment? That based on your ruggedness, how you design your system. That basically determined by the manufacturer rather than the government. So there are two parts, emission part and immunity part. Actually, the emission part government will impose, the immunity part the manufacturer will impose. Because sorry, countries like India, or suppose if you are so weak physically, the government should not say you should be kicked out from the country. They don't have the right. Right. Similarly, the equipments also, when the immunity is more, definitely you need to pay more amount. That is why the mobile phones, there are different ranges of mobile phone. iPhone is more. It's obvious. Their immunity is also more. They have a lot of features in the mobile hardware case itself. The another case, when you develop electronics and electrical equipments, sorry. So how do you ensure your equipment is not emitting more than this desired level? So all the developed equipments, so-called electrical and electronic equipments, you need to undergo different testing. That is called EMI-EMC test. Okay. After this EMI-EMC test, you will put a desired sticker on the equipment. So the so-called developed countries, this Western country, without this desired sticker, if you are keeping such equipments for sale in the rack of a shop, if it is not there, you may have to go to the jail. Okay. And Whereas countries like India, these types of stringent rules is slowly coming up. I will explain it later in detail. Now, I think you understood what is interference and what is electrocompatibility. So this energy coupling to the electronic devices, basically we can classify into 4 categories. That is radiated emissions, radiated, so radiated emissions, radiated susceptibility, conducted emissions, and conducted susceptibility. Or in emission itself, you have conducted and radiated, which means emitted signal propagate either through the air, that is radiated, or through the power line. I will explain in detail. And the susceptibility part, in US people, they will say immunity part rather than susceptibility. This is the word used in US, immunity. That is what is amount of conducted immunity and radiated immunity. You look into this picture, this is very clear one by one. What is a radiated emission? You look at this structure, this is our equipment, which is powered by a power line. And you can see the signals, they are leaving from the equipments or from the interconnecting wires. They are radiating out. That is the radiated emission. And the reverse is the radiated susceptibility. Suppose if you are operating a device, maybe a sensitive device, and when it is operating, the so-called polluted environment surrounding to your equipment from this atmosphere, they may couple into your system either to the interconnecting wires or directly to the device itself. Okay, this is the radiated susceptibility or immunity part. Now you look into the third one. What is the conducted emission? This is quite important. See, now I am using a PC, personal computer. You know, the personal computer, for running the computer, I need the power. In India, I need a 230 volt, 50 hertz. If it is in US, 110 volt, 50 hertz, we will plug the power cord to the PC or maybe mobile or laptop. So you know, within the system, if there is some lot of noise is generated due to the radiation and conduction mechanism, you know, there is the starting point, there is a transformer. So the transformer has a primary and a secondary winding. Primary winding is connected to the 230 volt supply. And you may say that there is a physical isolation, but it's not perfect isolation. Due to the inter-electrode capacitance which exists in the primary, what happens, you know, all these high frequency signal which is generated inside, they may be coupled to the primary. Once it is in the primary, what will happen? These high frequency signals are propagating through your power line. You know, the power line, it is a huge network, millions of kilometer network. Okay. See, that is the conducted emission. The reverse is the conducted susceptibility or conducted immunity. You see, if your equipment, suppose my PC is injecting a lot of high frequency signal to the power net, the next switchboard or the next room, the next lab, I am using another equipment like a spectrum analyzer or a network analyzer. I am plugged to the same power line. What happens? What is already injected into the power net, they will be coupled to the same method along with the 230 50 hertz supply. They are coming through the starting transformer into a device, and the device starts malfunctioning. So what you should do, you should provide the desired protection by providing sufficient filters. Okay, so for other things, radiated susceptibility, what we will provide? A shielding. Okay, so because of lack of time, I am not explaining all these things. I am just giving an overview, that's all. Now you see, this is another quite interesting thing thing, that is electrostatic discharge. You know, when you walk through your computer room or lab, especially during winter season, you know, where humidity is less, and you know, due to the friction of your shoe sole on the floor, the rubbing, you will be charged. Charge accumulation will takes place on your body. That is called triboelectrification. So this is more severe where winter season and where humidity is less, especially like just I mentioned the issue in Visakhapatnam. Actually, this was the culprit, ESD. And then similar to Delhi and wherever the humidity is low, the charge accumulation, you will keep on develop charge and charge will keep on accumulate on your body. Suppose if 1 microcoulomb charge is accumulated on your body, what is your body capacitance? I think you studied basic electromagnetic field theory that capacitance of an isolated sphere, we can compute C is equal to 4 pi epsilon naught A. If you neglect epsilon r is equal to 1. So suppose your human body, if you crush into similar to a typical Indian, like an average radius, cylinder and height, and you map this to an equivalent sphere, then you can compute the capacitance of your body. For a typical Indian, the capacitance will come around 50 picofarad to 1 ton picofarad. Okay. And with 1 microcoulomb charge and with this small capacitance, you know what is your body potential, how much potential has been raised. Potential V is equal to, use the basic formula, Q by E, V is equal to Q by C. You can roughly calculate your body is raised to a potential of 10 to 20 kilovolt. There is also a funny thing, you know, the high voltage is coming to females rather than male, because you know their body size is slightly lesser than male. So they are more dangerous than male. Okay. So you think of such a high potential, 10 to 20 kilowatts, if you touch a sophisticated instrument like this, what will happen? Suppose a CMOS IC is there in the front end. You don't know what happens. The entire charge that is accumulated on the body will discharge. Actually, this was the reason behind, just I explained, an explosion took place in near naval base in Visakhapatnam, because while cleaning their floor on the ship, they don't know, because you know, you don't know you have this much potential you are carrying or charge you have. So for that, nowadays people are using anti-static discharge, so many other precautionary measures before you enter into sophisticated instruments. Okay. So something is happening in between. Okay. So the next one, you look at here, this is another important thing, the electromagnetic pulse or a nuclear detonation. If you try to do some experiment, you know, our India, we conducted the Pokhran explosion. Such types of nuclear detonation, if you conduct, that will release a large amount of electromagnetic spectrum. And in fact, nowadays, our military or our Air Force, they are developing, the DRDO, they are developing electromagnetic pulse. You know a square pulse having a width of sufficient finite width delta. If you keep on increase, you know, if the pulse width, if you decrease, you know, the frequency spectrum, you have all frequencies. Suppose if you add up all frequencies together with high amplitude, then you can create a narrow pulse. If you discharge this pulse, suddenly all the frequencies are released. It's not so easy. Then what will happen? The entire frequencies are discharging below the ground. What will happen? Huge amount of frequencies are releasing instantaneously. The electronics equipments lying on the ground, they may damage or sometimes permanently destroyed. Actually, this is the type of equipment which used during Gulf War, US Air Force. In fact, Saddam was having a huge number of aircraft. What Americans did during the early morning, they will pass an aircraft very high altitude because they don't know what has happened. But what has done, the US Air Force, they released these types of electromagnetic pulse or electromagnetic bomb. What has happened? Their entire radar system collapsed, damaged. So without radar, you can't take off a flight. So that was the main reason why Saddam was defeated in the Gulf War, because he could not take even a single flight, because for take off a flight, you need the radar. You could not operate his entire radar in the aerodrome is completely first destroyed by the US Air Force. Then only they started bombing. So these types of electronic bombs are developed by in India also, and US, they have a large number of these types of bombs, like so-called developed countries, Russia, France, Germany, Britain, etc. And another example is a lightning. I don't want to explain this lightning, guys. And this is another quite interesting thing, that is a Tempest, transient electromagnetic pulse. When you type a message in your keyboard, due to the electrostatic switching nature of your switch, when you press one particular switch, that will radiate. Okay. If you if you sit even half kilometer or 1 kilometer away from your keyboard with a highly sophisticated receiver, you can receive these signatures. And once if you know the signature, what is for A and B, you have the uncoded messages. Okay, which means, these types of spying or tapping was done earlier, especially during wartime situation, or else during launching of new product by different companies. What the operator will do, operator will type initially the original message, then the computer will have the software that will code the message, and the coded message is the thing which is transmitting to the desired location. If you catch the coded messages, you can't extract the original information, because you need the coding software, decoding software. Okay. So, but when you are able to capture by this way, you have the original messages with you, so you can have the information. These types of things are done in wartime situation and launching of new products, etc., using the electromagnetic interference. These are certain examples. Now, I think I am going slow, and it is quite interesting to look into the history of EMC. So, radio interference started even after invention of radio by Marconi and then by Jesse Bose in the year 1930, and it will become more evident when after World War II. World War II, people used a lot of electronic and electrical appliances for radiation, radio navigation, aircraft, etc. Then at that time, this EMI also started increase. Then this becomes more severe once our technology started developing, when we discovered transistors, ICs, and microprocessor chips in 70s. Because once we invented transistors, ICs, and chips, what we did, we started packing more circuits and more oscillators in the given area, which means miniaturization started. So these EMI instances also becomes more severe. And another thing, the frequency spectrum also became more crowded when we switched from analog to digital domain. Then toward the end of 70s, the trend toward replacing analog signal processing with the digital signal processing began to accelerate. Almost all electronic functions were being implemented digitally because of the increased switching speed and miniaturization of ICs. Okay, so because of that, consequently, the occurrence of EMI problems also began to rise. Then how the control started? The control started by the government. The first, now that age also, today also, the US is the strongest military force. So they started facing a lot of accidents. So one typical example I mentioned. Then the Federal Communication Committee in US, they published certain rules and regulation in the year 1979 that required the electromagnetic emissions of all digital devices to be below certain limits. The intent of this rule was to try to limit the electromagnetic pollution of the environment in order to prevent or at least reduce the number of instances of EMI, because no digital device could be sold in the US unless its electromagnetic emission met these limits imposed by Federal Communication Committee, that is FCC. Parallelly, in Europe, there is an International Electrotechnical Commission. They convened a meeting in Paris in 1933, and they recommended the formation of an International Special Committee on Radio Interference, CISPR. Actually, it's a French word, to deal the emerging problem of EMI, I mean electromagnetic interference. Again, the CISPR reconvened after World War II in London in 1946, and subsequent meetings yielded various technical publications which dealt with measurement technique as well as recommended emission limits. Some European countries adopted versions of CISPR's recommended limits. FCC rule was the first regulation for digital systems in the US, and the limit follows CISPR recommendation with the variation peculiar to the US environment. And even the countries like Japan and all, they are using the different norms of CISPR. And there are various EMC regulations. Because of time constraint, I'm not explaining, the international, this already I mentioned. So the EMC regulations means what are the limits for the conducted and radiated emission limits for the equipments you manufacture. And similarly, what are the conducted and radiated immunity limits? These two are the limits. And the various organizations, the world, already mentioned CISPR, IEC, and Europe, they have their own European norms, that is called Senelec, and British, they have British standard. And India also, we started developing ISO standards regarding this EMI. And in Indian scenario, actually, Army, Navy, Air Force, and Railway, we already made their own norms. And ISRO also have their own norms. But what is lacking, our common public and domestic use, domestic equipment in India is still under development stage. Whereas in the so-called developed countries, they have very stringent rule for developing the electronic equipments, whether it is for military purpose, whether it is for commercial application, or it is for domestic application. What is the meaning of this rule? When you develop a particular electrical or electronic system, all these developed systems should undergo the stringent testing, EMI-EMC test. If the developed system is not satisfied, then such systems you are not supposed to stick the desired sticker on it, and you are not supposed to sell that system in that particular country. Suppose if you are keeping the track that I already told you, and if it is not satisfied with the test, then the shopkeeper might have to go to the jail. And this is clearly mentioned in the rules and regulation. You please listen, one more important point is there in that. Suppose the rejected item, it is barred in their particular country, for there is no bar for exporting. So you please listen, if the rejected item, if it is exported from US or Europeans to the India, they don't have any bar. Now the second thing, how these rules and regulations are coming up. There are a lot of things that depends on the commercial consideration, depends on the political consideration. Okay, what do you mean by political consideration? You know, in certain, if you develop your items in your country, they will give the rules less stringent. Whereas suppose if you want to import something from outside, the country will impose stringent rule. Like, you know, we are subsidize our own product like that. So these types of rules are existing in so-called developed country. So that is one of the reason. So far, our India, it has become very difficult to export electronics items to so-called developed countries. So we are mainly focused, our 80 to 90% of import is software rather than electronic hardware, because we don't have very good laboratories for these testing facilities. You can see a CE mark. Actually, the CE stands for, it's a French word, it's European conformity. You take any electronic device, keyboard or calculator, you can see so many FCC CE certificate. Actually, that is EMI certification. Okay, without that sticker, you are not supposed to sell in so-called developed countries. Now I will give you a basic thing, how these interference is taking place. I mean, how the emission is taking place. You know, an electronic circuit or electromagnetic radiating structure is said to be electrically small if its largest dimension is much smaller than wavelength. An approximate criteria is that the electromagnetic structure is electrically small if the length is less than 1/10 of wavelength. So this is more clear. You look at this picture, look at here, we have a processor of, you know, we don't have any 300 megahertz processor, a processor of 3 gigahertz. If 3 gigahertz mean, what is a wavelength? 10 centimeter. What is 1/10 of 10 centimeter? Only 1 centimeter. If 3 gigahertz, 10 centimeter is wavelength, then suppose, look into the PC, you know, we have so many interconnecting wires in motherboards, motherboard to memory, motherboard to so many other interconnecting wires. Definitely they will have few centimeters. Even you look at the keyboard, keyboard has more than 20 to nearly 1 meter length from keyboard to your CPU. Then when the signals of high frequency signals are falling on it, what will happen? They will pick up. Okay, and another thing, this digital processor, they are working on this 3 gigahertz square wave. Due to the Fourier series property, you know, this 3 gigahertz square wave will have their harmonic multiples, 6 gigahertz, 9 gigahertz, so that your wavelength becomes still lesser and lesser. Okay, so what happens? Your PC becomes more and more efficient radiator. Okay, similarly, you know, in a reciprocity theorem in physics, what it says, a good radiator is a good receptor also. So what is radiating, they will receive. So that is why the signals are getting coupled from equipment to equipment. Okay, so I think I will skip this portion. Just I will mention. So how do you measure these emitted signals? How do you measure the emitted electrical field or magnetic field or the voltages, etc.? It is another important thing. You know, we start from measuring 1 microvolt to 1 volt. 1 microvolt to 1 volt means 10 to the power 6 dynamic range. Such a huge dynamic range, it's very difficult to handle. So we use in EMI EMC unit, we compress the scale by using logarithmic scale. Okay, That is what the units what we use in our EMI EMC. So what type of scale we will use? Voltage gain, V out by V in 20 log, current gain, similarly I out 20 log, I out by I in. These are the things in microvolt. A typical example I will tell you. For example, if you take one voltage is equal to in dB microvolt, how do you define it? 20 log volt per 1 microvolt. So 1 voltage is 120 dB microvolt, which means 1 volt is 120 dB above a microvolt. So 1 microvolt is 0 dB. So 0 to 120 dB. So the scale has compressed. So all these voltages, currents, fields, etc., we mention only in dB values. Okay. Now the question, how to control this EMI, or else how you design your equipment compatible to each other. So there are basically two classes of electromagnetic compatibility requirements. One is mandated by the governmental agencies, and the second one is imposed by the product manufacturer. Okay, so the governmental agency, they will mandate basically the emission part, radiated emission and conducted emission, whereas the immunity part or the susceptibility part is boosted by the manufacturer. Okay, so the government can control mainly the emission part. So before entering to that, what do you mean by a digital device? What is the criteria for defining a digital device? So the definition of a digital device, any device which you develop above 9 kilohertz is called a digital device. If the operating frequency of the device which you develop is below 9 kilohertz, then they are not digital device, they is called a toy. So a toy no need to undergo for this measurement, EMI EMC measurement. So if you develop a device which operating frequency is above 9 kilohertz, then the device must undergo stringent measurement, EMI EMC measurement, and after successful measurement, which means if you satisfy the conditions of impose the country, depends on the country, it will vary from country to country, vary from organization to organization. Okay, that is what, because I don't have much time to explain all these things. If you are dealing a business with ISRO people, or if you are dealing with army people or a commercial public, their values and rules are different. I will just give you some basic rules. I don't know, I may be able to finish it. Okay, this I will skip. Now, by FCC, this is the most popular one in US, and most of the countries they adopted this one also. Again, we can classify your electronic devices. That too also various types of classifications are there. I am not going in detail of that. You can classify basic equipment, generic equipment, product developed equipment. This is one way of classification. The most important FCC basic classification, Class A device and Class B device. Class A device is those meant for commercial or industrial organizations, a big establishment. Whereas a Class B is those marketed for residential environment. I should say it is for a common public. Class B is for common public and Class A is for a big organization. Okay. Now, what are the various standards stipulated by this FCC? Now, we look at a quick look at conducted emission. So I told you that conducted emission is the signal that is injecting to the power net. So that is propagating to your huge network, power net. So through the power net, signal will propagate low frequencies, which means up to 30 megahertz, starting from ideally 0 hertz to 30 megahertz. So normally we won't measure low frequencies. Of course, we will measure low frequencies in military equipments, because in military, the electromagnetic environment for military systems are considerably harsher than that for commercial purpose. So for military equipment, we will measure low frequencies, but for commercial and domestic application, we must measure the conducted emission from 150 kilohertz to 30 megahertz. So you see here, what is permitted? Look at here, 150 kilohertz. If you measure, you can have microvolt or dB level 66 dB microvolt. This also you have a CUSAT peak and average value. I don't have time to explain more, but anyway, there are various peak value, average value, CUSAT peak value. CUSAT peak value, that is a specialty of EMI receiver. That depends on how the value is repeating. That depends on the annoyance factor. Okay. So this 150 kilohertz, if it is 66 dB and 500 kilohertz permitted value is 56 and up to 5 to 30 megahertz 60. So once if you develop a particular system, a typical example, suppose if you are designing an inverter and you check, inverter, it has a lot of switching circuit. If it is emitting a lot of high frequency signal into a power net, and if it is found greater than this value, this particular frequency, then you need to give some modification in your circuit. If it is below this, then only you will get the certification. Okay, this is the case for conducted emission. FCC CISPR for Class B device. Class B device for domestic application. You look at Class A device for a large industry or business establishment, this value is more. You see here it is 79 and 73. That is almost 10 dB more, because why Class A and Class B device, why the values are higher for Class A? Because a big industry establishment, they can afford money, they can afford the space. Whereas a domestic public, the common man, people like in India, in Mumbai and cities like Tokyo, you can see a lot of single room apartment where a man comes from the office and he will put on his mobile phone, his washing machine, microwave oven, TV, mixie, computer, everything very nearby. Okay, all they starts radiating and all this will add up the radiation. If they start malfunctioning, if the immunity is less, then what will happen? Nothing will work out, everything will be collapsed. That is why the domestic public, the instruments used for common man, government has imposed stringent rule. Whereas for industrial application, you can afford sufficient space. And number two, if you have these types of equipment, you can afford giving additional enclosure or even filters for protecting. That is why the industry, big organization, the rules are lenient, I should say. Okay, and for radiated emission, look at here, the radiated emission, all frequency signals beyond 30 megahertz. This chart has given up to 1 gigahertz, but now European people are measuring beyond up to 6 gigahertz, and the US people started measuring up to 20 gigahertz. Okay, look at here, 30 to 88 megahertz. This is for Class B, for common people, domestic application. This is measured at 3 meters. So the radiated emission measurement is another difficult one. The radiated emission, where you will keep your measuring device, the receiver, that is another important thing. So you will keep at 3 meters. Okay, at 3 meters, you see the values, these are the different frequencies, 40, 43, 74, etc. Whereas in Class A device, you look at here, so this I will skip. Class A device, it is measuring at 10 meter away. I told you that in industrial organization, they have a big space they can afford. So the same value, the radiated emission, actually the electric field will vary 1 by X. If you transfer this 10 meter to 3 meter, you can add 20 log 10 by 3. This will come around 10.5 dB. Then this will be quite bigger. Okay. So I think I will show you one plot here, comparison of Class A and Class B digital devices. The measurement distance made 3. So you see here, Class A, the rules are lenient, whereas for Class B, for a common public, the rules are more stringent for FCC. Okay, what it says, this frequency component, this much is the amount of electric field permitted. Okay, if your developed instruments radiate more than this electric field, you won't get the certificate. Either you have to discard the device, or you need to open it, like Indian people will reopen, and again we will do some adjustment to your circuit, and again test it. Actually the test is also a costly affair. That is another issue. Okay. And okay, so I don't want to explain more. This is a CISPR 22. This is another radiated emission for, I told you FCC is mainly for US, CISPR is for European country and some Japan and some Asian countries also. There are different variations of CISPR in different countries, Thailand, Korea, Japan, etc. Okay, this is for radiated emission limit. And you see there is a slight comparison of FCC and CISPR. You know, the environment will be different. You know, in a typical example, like, you know, how depending on their environment, their atmosphere, based on that, there is a committee. As I told you, IEC, FCC, and CELNEC, etc. They will sit together, and every 3 years, they will modify the strategies and these rules and regulation. They will analyze, keep on renew these things. Okay, what I am showing is the not the latest one, just to give an idea of what is CISPR 22. Now all these new versions will introduce once in every 3 years, because you know the rules are more strict and stringent to avoid these accidents. And anyway, the military, this is one typical example. I don't have time. You see here, starts from measuring from 30 hertz to 40 gigahertz. This is a mil standard used in US military. So each frequency, what is the emission level, what is the immunity level, that will be written in the document. Okay. Now the question, I don't know, is it useful? It is already 6:30 now. You tell, accordingly I will continue. Hello, Dr. Krishna?
Yes, sir.
Is it useful? Is it interesting? I don't know. How much
Sir,
time
you can have 10 more minutes. No issue.
Okay, let us see whether 10 minutes I can finish it. I will tell you, this is a big topic. I don't know.
Yeah.
If you are as highly specialized, accordingly I can do, because Dr. Krishna told you entire community is there, electrical, electronics. That is why I took this topic as a review introduction. And another thing, you know, this is important thing, because our India industry and research scientists, they are limping to this field only. And most of the academic institute also, they started teaching this subject very recently in their institutes. And I will tell you that one example around 10 to 20 years back, and I already told you that main export from India is mainly software rather than electronic equipments. You know, while exporting automobiles like, you know, Maruti and Tata, what they were doing earlier 10 to 20 years back, they will take all their developed vehicles in a ship and move towards the Thailand. Thailand, there is a very well established, that is the nearest station, EMIMC lab, that they will test it there, and with that they are selling, transporting from other so-called developed countries. That is the way we were practicing. And very recently, we have in VRE, that is Vehicle Research Development Establishment under DRDO in Ahmednagar. They are developing different army vehicles. They have a very good EMIMC testing lab there. Okay. Now, anyway, how do you test? That is a question. There are various testing, emission test and susceptibility test, immunity test, emission test, radiated emission. I will just have a quick look at here. This is a PC, and I'm keeping in a semi-anechoic chamber. You see here, there is a receiver. What is a receiver? Receiver, actually it is called a sensor. The sensor and antenna, it is quite different. Normal antenna we can't use. If time permits, I will explain that also. Which means the antenna is connected to the device, that is spectrum analyzer or network analyzer. What antenna will sense what is a radiated electric field from the device. Okay, so the antenna will convert this electric field into voltage. So the spectrum analyzer will give you the voltage reading. Now from this voltage information, by using the antenna factor, that is a property of the antenna, you may be able to find out what is the electric field intensity here. Now for that, you see here, we will use either 3 or 10 meter, depends on whether you are measuring class A equipment or class B equipment. Okay, how do you test it? We will run the device. If it is a PC, we will run the device and we rotate the antenna and we will rotate this device also. It is not an easy thing. You know, it will take days together to finish one measurement itself. All the orientation we need to look. Another one. Second one, we need to scan the entire frequency starting from 30 megahertz to few gigahertz. So we can't do it in single antenna. You won't get a single antenna also, such a huge bandwidth. So people are using different antenna for different frequencies. Log periodic antenna, conical antenna, broadband, this waveguide antenna, etc. Ridge antenna. Okay, I will show you one typical picture. A semi-anechoic chamber. You can see a automobile is sitting on the ground, and you can see different antennas are there. Log periodic antenna and dipole antenna. So many antennas are there, and the outputs of the antenna is connected to the control room. And what we will do, we will turn on the vehicle, and all the electrical and electronic appliances will be turned on. You know, nowadays the latest high luxury vehicles will have nearly 10 to 20 microprocessor. You know, all the processor will be turned on. That is another thing. In fact, I didn't get time. You know, suppose if one of the processor if is malfunctioning, and if you are the vehicle is moving in a high-speed national highway, you know, like in those so-called developed countries, if the sum of the emission, if it is coupling to the nearby vehicle without the knowledge of the driver, if the braking system is initiated, what will happen? Suddenly the vehicle will halt, get a stop. That may lead to accident. Such types of examples are also there. So because of time restrictions, I did not explain. So, and you know, we need to test these EMIMC, not only vehicles, we need to test even boats. Even in India, we have a testing facility in IIT Kharagpur, where we will give certification for the boats, okay, which is used for the fishermen. See, this is one example of how to test a tank. In these types of facility we have in Ahmednagar. And you see how the radiated emission in open area test site, how do you conduct it? We will rotate the equipment in rotating tables, okay, and then the radiation will pick up by the receiver. So receiver is a sensor. So the sensor will connect to the spectrum analyzer. You can see the voltage level from which what you will conclude. You will check whether the desired frequency is greater than the specified level, what is written in the document. If it is more, this item is rejected. If it is less, the item is passed. Okay, this is the way how we will test the various equipments in this EMIMC lab. Okay, and another thing, the conducted emission. The radiated emission test is this one. Conducted emission, I already told you that when you connect your equipment, this is the product. What will happen? The product, when you connect, we need the 50 hertz 230 volt supply to energize the product. So as I mentioned, the product is also generating a lot of high frequency up to 30 megahertz. They will be entering to this power line. We need to test this. How will you test it? We can't use, this is a conducted voltage and current. Here it is not field. What we are measuring, voltage and current. How do you measure the injected voltage and current? So for that, we are using an instrument which is called the line impedance stabilization network. What is this purpose of this network? In between the line and the product. So because you know, in your power net already it consists of a large number of polluted, injected, these low frequency signal. If you connect your product straight away, these signals along with the 50 hertz will creep into that. So we need to test the noise energy generated only the product. How do you block this thing then? We use this LISN. You look at here, this LISN is connected to, this is the 230 volt power line, and the back side there is a connection that is connected to the 230 line, and the output of the LISN is connected to the device, and LISN output is connected to spectrum analyzer. Okay, now I will show you a circuit. You see here, this is an LISN inside circuit. What it will do, it consists of the phase line, neutral line, and ground line. Okay, we need to check what are the frequencies injecting from the product to the phase and as well as neutral. So for that, first we need to block what is already present in the net. So for that, we are using capacitors, cross, and inductors parallel, I mean series. So these inductors and these capacitors, because of their values, they will block this 150 kilohertz to 30 megahertz, what is already present in it. So for this frequency range, these capacitor will act as short circuit, inductor will act as open circuit, they will block. Meantime, 50 hertz, this will act as short, capacitor will open, so 50 hertz line will enter. Okay, now the product will be energized. Let it be a mixie or your computer itself. So these high frequencies injected into the line, look at here, they will pass through this capacitor, and here we will connect our spectrum analyzer. That is the thing. Okay, so this output is connected to the spectrum analyzer. Now the spectrum analyzer will directly read the voltage what is injected into the power line. I think it is clear. This is the way how we will measure the conducted emission. And you can see this is one test is taking place at Samir, Calcutta. A mixie is connected to the LISN, line impedance stabilization network, and the output is connected to a vector network analyzer. And then radiated susceptibility, and the radiated susceptibility or the immunity part. How do you measure the immunity part? So this is another quite difficult thing, which means your equipment, you will expose to various types of electromagnetic radiation. A typical example, suppose a plane wave is falling on your circuit. You know, a plane wave, it's a time varying signal, both electric and magnetic field, that will induce voltages and current in your interconnecting wires, right? So what will happen? They will increase or decrease the voltage. That is a signal which is falling through the wire instantaneously. Okay, that is the noise, you may say that. So this, how much it is falling, and at what level it will fall, and what level this will start malfunctioning. That is the susceptibility part, immunity part. So for that test, normally we will use anechoic chamber. Okay, anechoic chamber, we can carry out both emission test as well as the immunity test. So for the immunity test, what we will do, use the reverse one. We will keep the equipment live, and the output of the equipment will be monitored, and we will transmit plane waves from the antenna. Okay, but the thing is that anechoic chamber is a very costly affair. You know, the cost of the anechoic chamber may vary from 1 crore to 20 crore. So a normal lab and normal common people, and it is very difficult to afford. So for that, we are using very different types of cell, that is called transverse electromagnetic cell, and gigahertz TM cell or GTM cell. People, normally EMIMC people, we will say the GTM cell is a poor man anechoic chamber. So where, what we will do, I will explain this GTM cell that is most commonly used. We can see we will develop a uniform plane wave region. The region will be less. You can see here, we will keep the equipment inside and it is closed. So which means it is a metallic. So all the external signals are blocked. And what we will do, the end, we will connect a signal generator. This can be from 30 megahertz to maybe gigahertz. Our equipment under test will kept inside GTM cell, and we will monitor its performance. It is a immunity test, and the same GTM cell can be used for emission test also. In that case, we will use here, instead of source, we will connect the spectrum analyzer or network analyzer, and the equipment will activate, for example, a mobile phone, and this will radiate, and radiated will be coupled, and it is connected to the spectrum analyzer. And this is the way how to measure emission part. And again, this is keep on going. I don't know how many people are interested. So I will explain to you this thing also, the antenna factor. I told you that normally those who studied in antenna in electronic area, they must have studied antenna characteristic, gain, etc. But that is not sufficient to measure, to use the antenna as a sensor, EMI sensor. So you know, when you connect your antenna to the spectrum analyzer, what is the output of the spectrum analyzer? The spectrum analyzer will give you the voltage. But what the antenna is exposed to the electric field. Now, what is the amount of voltage developed in the spectrum analyzer? That depends on the characteristics of your antenna, mechanical property of the antenna. So we should know how this electric field is converted into the voltage. So the ratio of the conversion of electric field to the voltage is called the antenna factor. Okay, once if you know the antenna factor, and if you know the received voltage in your spectrum analyzer, by multiplying this antenna factor and with the received voltage, you can compute what will be the electric field in that particular location. Okay, so this is one of the important factor. Normally, when we purchase antenna from market, people won't give it. If you want antenna factor, you need to give additional pay, starting from 25,000 to 50,000 or 1 lakh to get this antenna factor. Normally, people will provide gain and frequency plot. You take so in order to have an antenna factor, to have a reasonable amount of received voltage, from this expression you can see antenna factor must be as low as possible. So this also will represent normally in dB. And you see a typical example of an antenna factor of a typical antenna developed by Andrew in Japan. With various frequencies, this will be the antenna factor. From this plot, you can use this plot for computing the electric field. This is keep on going on. I think this is another. I will tell you, this is a very big area. And I hope you got some input, some idea what is EMIMC. If you have a few questions, then I can clarify, I can explain it. I think I will stop this at here. With interruption. Because Krishna's told me to give 10 minutes. Now I took more than 15 minutes. Okay, do you have any specific question?
Right. Thank you, Abdullah sir, for that very wonderful session. Thank you for spending this time.
Okay.
I think we'll give some time for questions.
Yeah, of course. If any
so
specific question is there, I can.
there are a few people I think who are interested.
Okay.
And after that, we'll go to the vote of thanks. So we'll have maybe for some time for questions. So if any of the participants have any questions, they can either unmute and maybe talk, or they can post it in the chat window. Abdullah sir, just in the meantime, I think until when people are
that is okay.
Regarding this compatibility, is this compatibility field of compatibility related to this SAR that people talk about?
That is also important thing. That is another area actually, a specific absorption rate. Specific absorption rate, that is a biological hazard. That is another issue. That is, in between I told you, that if you purchase an iPhone, why the cost of the phones are more compared to other things. So the SIR is good for this iPhone rather than in Nokia, Samsung, and Motorola. And that is because I don't have time. Microwave oven. What is the principle of microwave oven? The food is cooked. How the food is cooked in microwave oven? In the microwave oven, the frequency of the microwave signal is 2.45 gigahertz. Okay, so in 2.45 into 10 to the power 9 times per second, the molecules will vibrate. Okay, so these vibration create a huge friction. That is why the heat is produced. That is the way how the food is cooked inside a microwave oven. And similarly, you look into your mobile phone. What is the frequency of your mobile phone? Nearly 900 megahertz and some other 1.8 gigahertz. Roughly the almost same. If you are keep on talking with the mobile phone in your ear, what will happen? This frequency, it is high power is transmitting not only to the atmosphere, it is transmitting to the brain and ear, etc. So it is keep on exposed continuously, half an hour, 1 hour, etc. What will happen? Your molecule starts vibrating, you may feel fatigue, you may feel headache, and a lot of research has done. Even our Dr. Girish Kumar, Professor Girish Kumar from IIT Bombay, yes, conducted an extensive study regarding this, and he found in Mumbai that so many apartment people have caused a lot of cancer. Cancer is more than 4 to 5 times due to this mobile phone. It is not only mobile phone, because of mobile tower location. The tower power is, multifold, more than 20 watts to the 30 watts. Your mobile phone may be less than 1 watt, but tower power is more than 20 watts. Because of that, a lot of biological hazards are there. There is another interesting area. But because I focused on EMI, EMC, I'm not discussing that part here.
No, that's okay, sir. Thank you.
Yeah.
I just want to know if it's a part of EMC or not, or if it's a separate.
Everything is interconnected. SAR is also interconnected. Okay.
That's all from my side.
Thank
If
you.
there are any further questions from the participants, they can ask.
Any
If not, I
question?
think.
Okay,
Don't
then.
see anything. Okay, so
I don't know.
in which case, I think one of our sirs, Professor Santosh, he is in the electronics department.
Okay.
He'll be saying the vote of thanks.
Okay, thank you.
Santosh, sir?
Thank you, Krishnamurthy, sir.
Okay, go on.
Thank you, Krishnamurthy, sir. Good evening, all. On behalf of IEEE Students Branch, Abdulla School of Engineering and Technology, I extend my heartfelt gratitude to Abdulla, sir, who spared his valuable time with us to deliver this informative session. Thank you, sir. Also, I would like to thank IEEE Malabar Hub for the opportunity to host this webinar. And finally, I thank all the participants present here. Thank you all.
Okay, thank you.
Before leaving,
okay,
please fill the feedback form that I've shared in the chat box. Thank you all.
Okay.
Okay, thank you, Abdulla, sir.
Okay, thank you.
Thank you, Abdulla, sir.
Okay, thank you, Sabik.
Okay. Thank you, Sabik, sir.
Bye.
Okay, thank you.
Then shall I leave then?
Yeah, sure, sir.
Okay.
Thank you, Krishnamurthy, sir. Santosh, sir.
Okay.
Bye.
All right. Thank you, Sabik, sir. All right.
Okay,
See you.
bye.
Thank you, sir. Thank you, sir.